Hello everybody. Today we will start our third lesson, position of a circle with respect to another circle. If I have two circles M and N with radii lengths R1 and R2, I consider that R1 is the radius of the first circle M and R2 is the radius of the second circle N and R1 greater than R2, like this. These two circles are distant. I have 6 positions. This is the first position, distant. What is the meaning of distant? The distant circles, it means the length of Mn is greater than R1 plus R2. For example, if I have R1 is equal 3 and R2 is equal 5, so Mn must be greater than 3 plus 5. If I wanted to find the intersection between circle M and the intersection between circle N, it will be 5. And intersection between surface of circle M and surface of circle N also is equal to 5. Number 2, or the second case, touching externally. Touching externally, it means the two circles are touching like this. In this case, we'll find that Mn is equal R1 plus R2. If I wanted to find circle M intersection circle N, it will be set of A, this point. And also, the intersection between surface of circle M and surface of circle N, it will be A also. The third position, if we have intersecting circles, it means circle M intersects circle N at these 2 points, A and B. In this case, I find that Mn greater than R1 minus R2 and less than R1 plus R2. If I wanted to find the intersection between circle M and circle N, it will be set of these 2 points only. It means set of A and B. But if I wanted to find the intersection between surface of circle M and surface of circle N, it will be this colored part. The fourth case, touching internally. Touching internally, it means the two circles like this. Circle N inside circle M, but they are touching at the point A. In this case, I find that Mn, length of Mn is equal R1 minus R2. What is the intersection between circle M and circle N? Set of A. But what is the intersection between surface of circle M intersection surface of circle N? Surface of circle M intersection surface of circle N, I find this part, all of this part. It means circle N, like this. It will be equal surface of circle N. It means all of circle N, surface of circle N. The fifth case, if one inside the other, one inside the other, it means circle N inside the circle M, like this, but no touching here. So in this case, Mn must be less than R1 minus R2. What about if I wanted to find intersection of circle M and circle N? Here I haven't intersection, it will be 5. But surface of circle M intersection surface of circle N, it will be surface of circle N. The last one, concentric circles. What is the meaning of concentric circles? It means the two circles have the same center, like this. This is the circle M, and here circle N. So, Mn must be equal 0 in this case. If I wanted to find intersection between these two circles, it will be phi. But intersection between surface of circle M and surface of circle N, it will be surface of circle N. Here I have exercise to explain what I mean. If two circles are concentric, then it will be 0. Mn is equal 0. Here, touching internally, if Mn equals R1 minus R2. Touching externally, if Mn equals R1 plus R2. If Mn less than R1 minus R2, so I find circle inside the other. If Mn greater than R1 minus R2 and less than R1 plus R2, the two circles are intersecting. If Mn greater than R1 plus R2, then the two circles are distant. Let us see this exercise. Here I have two circles M and N with radii lengths 9 cm, that's R1, 9, and R2, which equal 4. Show the position of each of them respect to the other in the following cases. Here I have Mn is equal 13. But before I find or I solve this exercise, I must find R1 minus R2. It means 9 minus 4, it will be 5, like this. R1 minus R2. And R1 plus R2, it will be 13. So I can write here 5, and here I can write 13. Now I want to determine the position of the circle with respect to the other. Here I have, if I have Mn equal 13, it means here then the two circles touching externally. It because Mn is equal R1 plus R2. If I have Mn equals 5, it means the two circles touching internally because Mn is equal R1 minus R2. If Mn equal 3 between 0 and 5, then the two circles, I find one inside the other. It means here. Because Mn less than R1 minus R2. If Mn equals 0, it means the two circles are concentric. If Mn equals 10, I find that 10 between 5 and 13. It means the two circles are intersecting. If Mn equals 15, it means Mn greater than R1 plus R2, so it will be distant. It means I need to know this line to solve this problem. Here is the same line. After that, I have two important facts. The line of center of two touching circles passing through a point of tangency and is perpendicular to the common tangent. And the line of centers of two intersecting circles perpendicular to the common chord and bisects it. We'll see this through exercises. In this exercise, I have M and N are two intersecting circles. I have two intersecting circles. C belongs to PA, ray, and D belongs to the circle N. Measure of angle MND equals 125. Measure of angle BCD equals 55. I want to prove that CD is a tangent to the circle N at D. To prove that CD is a tangent to the circle N at D, it means I want to prove that measure of this angle is equal to 90. I need to prove that measure of this angle is equal to 90. If I prove that, so CD is a tangent to this circle. How can I prove this? Here, if I have two intersecting circles, it means the line of centers. What is the line of centers? It means MN is perpendicular to the common chord. Where is the common chord? Which is AB. then MN is perpendicular to AP. And also MN bisects AB. It means AE is equal to EB. And MN is perpendicular. It means the measure of this angle is equal to 90 degrees. So if I have measure of this angle which represents CEN is 90, and I have CEND is a quadrilateral, so I can find the measure of angle D or CDN. Because we know that sum of measures of interior angles of quadrilateral 360. So measure of angle D 360 minus 90 plus 55 plus 125. It will be 90. Let us see the proof together. Here I have M and N are two intersecting circles. It means MN is perpendicular to BC or AP. They are the same. It means measure of angle CEN is equal 90 degrees. This angle is 90 degrees. And we know that sum of measures of interior angles of quadrilateral equal 360. So measure of angle CDN 360 minus 90 plus 55 plus 125. It will be 90. Then CD is a tangent to the circle at circle N at D. We'll move to another exercise. Here I have M and N are two intersecting circles at A and B. C is the midpoint of XY, and the measure of angle D is equal to 40. Here D is equal 40. FZ is a tangent to the circle N. MN intersect straight line FZ at this point F. I wanted to find the measure of angle CME, measure of this angle CME. Before I start, we learned it before. If I have a chord like XY and I have a midpoint like C, then MC is perpendicular to this chord. I can write it directly. It means the measure of angle MCX or MCD is equal 90. And also I have these two circles are intersecting circles. It means the line of centers, which represents MN, is perpendicular to the common chord AB and bisects it. Means AE is equal to EB, but I don't need it now. I need to use the perpendicular. It means MN is perpendicular to AB, then measure of this angle also equals 90. And we proved before that measure of angle MCD is equal to 90. So I have a quadrilateral. It means I can find the measure of angle CME, which equals 360 minus 90 plus 90 plus 40. It will be 140 degrees. That's the first required. About the second required, I want to prove that FZ is parallel to AB. FZ is parallel to AB. But we know that FZ is a tangent. FZ is a tangent. If FZ is a tangent and NF is a radius, it means measure of this angle is equal 90 degrees. This angle is 90. This angle is 90. And also we have measure of this angle is 90, AB. It means sum of these two angles, sum of measures of these two angles equal 180. Two interior angles are supplementary. It means AP is parallel to ZF. Or measure of ZFN is equal AEM, two corresponding angles. Like letter F, it means FZ is parallel to AB. So I have here FZ is a tangent and NF is perpendicular to FZ. It means the measure of this angle equal 90. So FZ is parallel to AB because measure of angle ZFN, this angle is equal to measure of angle MED or MEA, corresponding angles. Thank you for watching. Meet you in the next lesson. Goodbye.